good evening. Well, I expect you'll realize straight away who this is. Major Yuri Gagarin, just about to report mission accomplished to Mr. Khrushchev. The first man in space, the first spaceman in history. You know, if I'd come on the air in 1957, when we did the first of these Sky at Night programs, and said that within 5 years I'd be showing you pictures of the first man to go round the Earth in orbit in a spaceship, well, I think you'd have regarded me as mad. But nevertheless, it has happened. And the great question now is, what is going to happen next? Well, undoubtedly, this flight of Gagarin's is one of the essential preliminaries towards man reaching the moon. But of course, that won't come yet a while. I think myself that the next step is going to be a soft landing of an unmanned, instrumented probe upon the moon's surface, which will act as a real lunar transmitting station. But I have no doubt either that the first manned flight to the moon will take place in the foreseeable future. And so I think this evening I'd like to say something about the moon itself. Because after all, if we're planning to go to a strange land, one of the first things we do is to find out as much about that land as we can. And exactly the same kind of thing applies to a strange world. And in many ways, the moon is a very strange world indeed. From Earth, of course, we can only see just a bit over half of it, because the other half is always turned away from us. But I don't think any of us are going to forget that magnificent moment when we first saw pictures of the moon's other side, sent back by the Russian vehicle Lunik 3 in October 1959. Well, I showed those on the screen at the time, and one or two of the pictures have been quite widely published over here. But when I was in Moscow last autumn, I saw over 30 more, and they were then being combined into an atlas. Well, now, that atlas of the other side of the moon has now been produced in Moscow. It's been done by a team headed by Professor Lipsky, and he's been very kind and sent me a copy of it, and this is actually it. Quite a lot of tabular matter in here and text stuff. I'm afraid I can't read Russian, but the technical stuff is fairly easy to make out. And then we have these other pictures of the moon's far side. Some of them showing large areas, and some of them showing smaller areas on a larger scale. Here, for example, we've got one which shows part of the surface which we know quite well, and another part that we've never seen before. We have, for example, that small, well-marked waterless sea, which we call the Sea of Chryses, or the Mare Chrysium. Now, that's visible on the Lunik pictures, but it's also visible on many pictures taken from Earth, because it's a conspicuous feature of the visible side, and you can see it with any small telescope. Now, here I've got two pictures. The one on the left-hand side is the Lunik picture, and the one on the right-hand side is a picture taken from Earth. And you can see that this very conspicuous dark plane is easily recognizable upon both those charts. Now, as well as the atlas, and as well as the photographs, there is now a comprehensive chart of the moon's far side, which again has been drawn up by the Russian astronomers headed by Lipsky. And I thought you might like to see that, so we've made a very large blow-up of it and we've brought it along. The first essential thing about it is that the other side of the moon is just as thickly covered with craters as the side which we've always known. Although, of course, these craters don't show up very clearly on the Lunik pictures, which aren't, naturally, very well defined by our normal standards, magnificent though they are. This area is part of the moon we've always known. And then here we have a range of mountains, the Soviet mountains, which may be quite high. Up here we've got the well-defined dark plain, which the Russians call the Moscow Sea, with the Bay of the Astronauts. And down here we have the crater which has been named after the great Russian spaceflight pioneer, Konstantin Tsiolkovsky, the first man who suggested exploring space by means of rocket power. Now, all those pictures that you've seen are based upon the photographs sent back by Lunik 3. But one of the things I would like to know is what happened to Lunik 3 itself. And quite honestly, we don't know that, because its transmitters suddenly ceased to operate. When I was over in Moscow and I was talking to Professor Misevich about it, she said that she was quite sure that Lunik 3 had been hit and damaged by a meteorite. I'm quite certain she was right, but I don't suppose we'll ever know for certain. Well, now, if we are going to get to the moon eventually, what then is the kind of a world which we may expect to find? Well, I can't yet show you any actual pictures taken from the moon's surface, but we can show you what I think is a very reliable drawing of what it may be like. This was made by David Hardy, and it shows one of the great lunar craters with a raised wall and a central elevation. And there are thousands and thousands of those upon the moon. but the entire landscape is quite alien from our point of view, unlike anything that we have on the Earth. And most of the differences between the Earth and the Moon arise from the fact that the Moon has pretty well no atmosphere. Now, there's a very good reason for that. We know that the Earth is able to hold on to a very dense atmosphere, the air we breathe. And that's because the escape velocity of the Earth is very high. If you started off a projectile straight upwards, then if it were going to get away from the Earth, it would have to travel at 7 miles a second, or about 25,000 mph. That's the Earth's escape velocity. Now, we know that atmosphere is made up of innumerable small particles of atmosphere moving about at high speeds. Now, they can't get away from the Earth because they can't work up to the Earth's escape velocity. But things are very different indeed on the Moon, where the escape velocity is much less, only 1.5 miles per second, because the Moon has only 1/81st of the Earth's mass. Now, I suppose it's quite possible that millions and millions of years ago, the Moon may have had a dense atmosphere, but it was unable to hold it down, and nowadays the Moon has practically no air left. I say practically because there may be just a little, but certainly not very much, and there's a very easy demonstration of that, made by practical observation. In its path among the stars, the Moon sometimes passes in front of a star and occults it. Now, if you have the Moon passing in front of a star, and you assume that the Moon has air around it, that star will flicker and fade for several seconds before it disappears, as actually does happen when the planet Venus goes in front of a star, because Venus has got an atmosphere. But it doesn't happen with the Moon. And when the Moon occults a star, the star shines steadily right up to the moment of its disappearance, and then it snaps out instantaneously. And that alone shows us that the Moon's atmosphere can't be as much as 1/10,000th as dense as that of the Earth, and it's probably a lot less than that. That means, too, that there's nothing to protect the Moon's surface from extremes of temperature. And at midday on the Moon's equator, the temperature rises to something like 220 degrees Fahrenheit, which is above the temperature of boiling water. But at lunar midnight, it becomes very cold indeed, and the temperature sinks to about -250. And you can see straight away from this chart that the extremes of temperature on the Moon are very much greater than is the case for the Earth. So in that respect, too, the Moon is a very uncomfortable kind of world. All this has some influence, I think, on the problem of where the first manned spacecraft are going to come down. Well, I've got my own ideas on that. I may be quite wrong, but anyhow, I'll give them for what they're worth. To start with, when you're going to land on the Moon, you cannot avoid the bitter cold of lunar night, because the nights are equally cold all over the Moon. But the daytime heat isn't equally great anywhere, and it's at its greatest, of course, near the Moon's equator. Now, I've got a large composite photograph of the Moon here, showing the visible side, the side that you can examine with any telescope from the Earth, and I'd like to show you what I mean by that. Here we have many of the mountains and craters. There's the Sea of Chryses, the one that I showed you on the Lunic pictures. There's a well-known crater, Ptolemy, nearly 100 miles across, and so on. Now, this is the Moon's equator, more or less, and that's where the daytime heat is greatest. But if you go to further north or further south on the Moon, then the daytime heat will not be so great. And so I think it'll be wise for the first explorers to come down well away from the Moon's equator. And my guess, for what it's worth, is that the first landing is liable to take place in this large, dark plain, which we call the Sea of Showers, or the Mare Imbrium. I may be quite wrong, but I think that seems as good a place as any, and it seems to have every possible advantage. But of course, we don't yet know much about local conditions. Well, now, one very interesting point. When the first explorers land on the Moon, are they going to find any natural life there, or are they not? Well, I'd like to go into this a bit, because there are all kinds of points to be raised here. First of all, the Moon has no air to speak of, certainly no water, and it's in every way a most inhospitable kind of place. Conditions are quite wrong for any human or animal life as we know it. And we can say definitely that men or animals built on our own pattern do not exist. There's no question about that. On the other hand, there's a question that's been put to me many times recently by a great many people, and I think I better answer it now because it is such an interesting one. Oh, incidentally, I'm afraid this is the place where I've got to say with the greatest reluctance that I've had so many letters recently that although I've tried my best to answer them all, I'm afraid I haven't succeeded. I just can't deal with any correspondence at the moment. I'm terribly sorry about that, but when you get hundreds of letters, well, there's just nothing you can do about it. I can only apologize. Now, the question that's been put to me so often is quite simply this. We couldn't exist on the moon. Well, that's quite reasonable. Conditions are wrong for us. But surely you could have some other kind of life which could exist quite well under lunar conditions and wouldn't have to bother about an atmosphere. In fact, there could be alien life of the kind that storytellers call the BEMs, or bug-eyed monsters. Well, now, let me say here and now that we can't prove that bug-eyed monsters don't exist, but we do think that they are improbable, and I'd like to explain why. It all depends not on what we know about life, but on what we know about living matter. Now, we know that all the material in the universe is made up of 92 fundamental elements. Now, I've got examples of some of those elements here. Here, for example, is tin. Here is some lead. Here is carbon, silicon, and a gas, helium, and a liquid element, mercury. And we can show that all the material in the universe is made up of combinations of these 92 fundamental elements. This is not speculation, this is fact. Now, we also know that there are only two elements whose atoms are physically able to build up into the large and complex atom groups or molecules which we need for living life. Those are carbon and silicon. And silicon's not very good at it, and so I think we must resign ourselves to the fact that living creatures, wherever they may be, must be based upon carbon. Now, I'm not suggesting that they must look anything like ourselves, but after all, I mean, there are many diverse forms even on the Earth. There's not much outward resemblance between, oh, shall we say, a jellyfish and an ant and a man. At least I very much hope not. But they are all based upon carbon, and they all need certain conditions. They need an atmosphere, they need water, and they need a reasonable temperature. None of those conditions exist on the moon. And although we can't claim that we know that alien life forms don't exist, there's no evidence that they do, and there's a great deal of indirect evidence that they don't. And so I think bug-eyed monsters are out too. But, of course, plants or living organisms of a lower kind are much more adaptable. And it's been suggested that these might exist on the moon. Now, one of the most favored spots is the crater Eratosthenes. There it is, a well-known crater nearly 40 miles across. And many years ago, the American astronomer Pickering suggested that certain dark patches inside Eratosthenes might be made up of a living matter. Well, I think all the evidence now is against that, but it was an interesting suggestion. We also had this bright crater down here, Aristarchus, which shows strange bands coming out from inside it, dark streaks, if you like, and it was suggested that those too might be due to living organisms. But again, all the modern evidence is against it. So I think we can sum up quite concisely. Animal or human life of the kind that we know just can't exist on the moon because conditions are all wrong. We have no evidence of alien life forms, and all the evidence we have indicates that they don't exist on the moon or anywhere else. And even primitive organisms of the plant variety are unlikely. And so when the first explorers reach the moon, it is not probable that they will find any living thing. But of course, I'd be the last to claim that we've yet got all the information, because we haven't. There may be some things we don't know about or haven't taken into account. And it's quite on the cards that the first explorers who rarely reach the moon, as they will do in the foreseeable future, are in for a great many surprises. Good night.